Okay, so this is really picking up from where we left off last week. Last week, if you remember, we started solving systems of equations using the elimination method. So what's a little different about the elimination method or graphing is our variables are not all by themselves. Okay, where when we are graphing, we wanted like y equals, and then whatever the rest of our equation is. In substitution, we wanted to have either an x or a y alone. In elimination, it looks differently. Okay, your x's are lined up, your y's are lined up, okay, and then your equal signs and the answer are lined up. So they look different than the other types of problems. What we talked about last week and started dealing with is how you can either add or subtract in order to get something to cancel out, to eliminate, to equal zero. So if we look at this problem, I notice that I've got a negative 6x in the top of my first equation, and in the bottom on my second equation, I've got a positive 6x. So when I think about this for a sec, okay, a negative 6 plus a positive 6, that's going to equal 0. Okay, so what we would say is that the negative 6 and the positive 6, when we add them together, they eliminate. That only leaves us then with the y's in the problem. That makes it a lot easier to solve. So what we're going to do is add the rest of our problems together. So 5 plus 4y leaves us with 9y. A 1 plus a negative 10. Okay, here's a place where you might want to grab your calculator and just double check your signs. 1 plus negative 10 is going to leave us with negative 9. Then we've got to get the y by itself. So this 9 here, we're going to divide both sides by 9. That way we can get our y alone. Then we've got negative 9 divided by positive 9. That equals a negative 1. Okay, so this is a big thing that came up a couple times on some of our Edpuzzle problems last week. Is one of the questions asked, how do you find the other variable once you have one of them? How do you find x once you have y in this case? Okay, so that how we're going to do this comes back to our magic word that we've used all year long, is we've got to substitute. Okay, we've got to take one of our equations that we have up top, and it really doesn't matter which one you pick. They're both going to take you about the same number of steps here, but we're going to substitute in. So because it doesn't look like there's that much of a difference here, I'm going to take my top equation. I'm just going to copy it down. Negative 6x plus 5y is equal to 1. You know what I love to say, work smarter, not harder. If there is an equation that looks a lot easier than the other one, that's what I would pick. These two look about the same, and they really are. So we found y, so we're looking for x. So everything else is going to stay the same, except where we see that y, we're going to replace it with a negative 1. That's the only thing that's going to be different. Okay, so I don't know negative 6x yet, but I have multiplication here that I can do. 5 times negative 1 gives me negative 5 equals 1. Okay, I want to get my x alone. I'm going to add 5 to both sides. Negative 6x comes down. Okay, 1 plus 5 gives me 6. To get rid of this negative 6 here, it's attached by multiplication, so I'm going to divide both sides by negative 6. And then I would put this in my calculator if I'm not sure, or I just do my division. 6 divided by negative 6 leaves me with negative 1. So now I have both variables. In these problems, unless it only tells you to find one of them, the expectation is that you find both answers, both variables, the x and the y. Last thing, a lot of times they're going to ask us to write our solution as an ordered pair. So when they want our solution as an ordered pair, we write it with our x first, x then y. For this one, it just happens to be our x is negative 1, and all the way back at the beginning, our y is negative 1. Okay, that doesn't happen all the time. So just make sure that you're doing your X, then your Y. Okay, I'm going to scoot this down to the next problem because we can see that there's something a little different that we're going to say. Okay, so in example 2, we've got our two equations. Everything's lined up all nice, the X's and the Y's and the answers. Okay, and I look, I've got 5 and 10x, 1y and negative 7y, and then I have my answers 9 and negative 18. So if I were to check these, and I'm not going to write it down, but if I were to mentally try to add these together, 5 plus 10 gives me 15. Okay, and this is really a 1y, so 1y plus negative 7y, well, that gives me negative 6y. So neither the x's or the y's would cancel out right now. What we would have to do is manipulate one of the equations in order to get the opposites or the inverses that we need. So we get to make a choice, and we could choose to eliminate our x's or choose to eliminate our y's. Well, for this problem, only because I think it's a little bit easier, I'm going to look at my y's, okay? And the reason why I picked y to get rid of is that is a 1y there. Ones are very easy to change to any number that we want, and the only way that we can change things is by multiplying. So if I look down at the bottom here and I have a negative 7y, I want to change this one to a 7. So what I could do is I can take this whole equation. I can't just do part of it. I've got to do the whole thing, but I'm going to multiply it by 7. And what I like to do to keep myself nice and neat is I write my new equations right next door. So I have 7 times 5x gives me 35x. I've got 7 times 1y. That gives me a positive 7y. I've got my equals. And then this is the part that people forget a lot. We also have to multiply 7 times 9. 7 times 9 gives me 63. Nothing changed down on the bottom on that second equation, so I'm just bringing that along. And I'm keeping it nice and lined up. So now that everything is rewritten, everything's still nice and lined up, I can add my two equations together. 35x plus 10x gives me 45x. Positive 7y plus negative 7y, there's my opposites. They're going to cancel out because they'd equal 0. Equals 63 plus negative 18. Typing that in my calculator quick here so I don't make a mistake. And 63 and negative 18 gives me 45. Okay, last but not least, x needs to be alone. So that 45 is attached by multiplication. So I'm going to do the opposite, and I'm dividing both sides by 45. Bringing that x down, 45 divided by 45 leaves me with 1. So I've got my one variable, and I don't want to be tempted to stop, but I know that I have two variables. I have x's and y's here, so I've got to find the y. So I'm going to take my x again, and I'm going to substitute. So when I look at my two equations up above, I think that this top one looks a little bit easier. So I'm going to use that one. 5x plus y is equal to 9. So my x is 1, so I'm going to replace my x in my problem. I have a little multiplication to do. 5 times 1 is 5. I've got to get y alone, so I'm subtracting 5 from both sides. 9 minus 5 leaves me with 4. So now, that one wasn't too bad. It only took like 2 steps, really. Multiplication, then subtracting over. So that wasn't too bad at all. Last but not least, we're going to write our solution. Okay, so we're going to write our solution as an ordered pair. So when we do that, we're going to put our x first, and then our y. So we've got the point 1, 4. So if we were to graph these two lines, that would be where our equations would cross, our lines would cross. Okay, last but not least, our last example for today. Whoop, a little too far. There we go. Okay, so this example, we've got 3x minus 2y equals 2 as our top equation, and 5x minus 5y equals 10. There's our bottom equation. Okay, so with this one, nothing's opposites here. I got a positive 3x, positive 5x. If I add those, that's going to give me an 8x. So that's not equal to 0. Negative 12 plus negative 5, well, that gives me negative 7. So that's not equal to 0. So I've got to change something again. I have to manipulate it. So the only way that I can change these equations is if I multiply. So I've got to make a decision. Do I want to get rid of my x's or my y's? So I'm looking, does 3 go into 5 evenly? No. Does 2, not even worrying about the negatives right now, does 2 go into 5 evenly? And that doesn't either. So it's not going to just be one quick equation that we have to change. We're going to have to change both. So when we are looking at this one, and I look at these numbers, 2 and 5 are a little smaller than 3 and 5, not by much, but a little. So I think I'm going to work on these and get rid of my y's this time. I could do this with my x's. It's really up to you. I'm just making a choice. Oop, and my battery is getting low. Okay, so I'm just making the choice right now to get rid of my y's because those numbers are just a little bit smaller. Okay, so I'm going to take my top equation here, and I'm going to multiply it by a positive 5. And then I'm going to take my bottom equation, and I'm going to multiply that by 2. Now, how did I come up with those two numbers? If you look here, the ones that are attached to the y, the easiest way to get things to cancel out is you're taking the number that's in front of the y in the bottom, and that's going up in the top. You're taking the number in the top here that's attached to the y, and that's going in the bottom. It's the easiest way to get your numbers to match. The other thing we've got to check, though, is we want these to be opposites. 2 times negative 5y gives me negative 10y, and 5 times negative 2 gives me negative 10y again. Those are the same numbers. They're not opposites. So what I'm going to do is I'm going to just change one of my signs here because I know a negative times a negative gives me a positive, and I could have changed either one. So I'm just going to go ahead and start distributing here, just like I did up top, so to all 3 parts. So 5 times 3 gives me 15x. 5 times negative 2 gives me negative 10y. And 5 times 2 gives me 10. Okay, I'm going to switch colors here, doing the same thing now with this negative 2. Every single part has to get multiplied. Negative 2 times 5 gives me negative 10x. Negative 2 times negative 5y. Oh, there's my positive 10y. And negative 2 times 10, negative 20. Okay. So now I have those opposites in the middle, those additive inverses. I'm all set to add these together. 15 plus negative 10 gives me 5. So I've got 5x. Negative 10 plus positive 10, that equals 0. So that cancels out. 10 plus negative 20. This I'm putting in my calculator to make sure I get my signs correctly, and I get negative 10. Okay, and I'm going to go ahead and divide both sides by 5 to undo that multiplication. Negative 10 divided by 5 is negative 2. So after all of that hard part up front of multiplying every single part here, becomes a very easy one-step equation to solve. The last part of this is we've still got to find our y. Okay, so I get to pick whichever one. I'm just going to pick the top one. That's usually the one I pick unless something is way easier. Okay, and I'm taking that negative 2 and I'm replacing it in for my x. Whoop, y equals 2. Okay, 3 times negative 2 is negative 6. So before I start moving things around, I've just got to make sure I got things straight. Okay, I've got to get y alone. So I'm going to move my negative 6 first. So I'm doing the opposite and adding. If you need to draw lines through your equal sign to keep things straight, that's fine. Bringing down my negative 2y. 2 plus 6 gives me 8. Okay, last move, dividing both sides by negative 2 to undo our multiplication. 8 divided by negative 2 is negative 4. So now I've got my x, I've got my y, I'm all ready to write my solution. Okay, so x always first, negative 2, comma, negative 4. So I hope that you guys found this useful. You were able to follow along. I'm going to post these notes onto Google Classroom along with the link to the video. So that way you guys can go back and reference anything, see kind of what I did. Please don't mind my handwriting. I know it's a little messy, but hope if you guys have questions or anything, please let me know, email me, send me a message on Remind, Google Classroom, so anything that you guys need. Okay, and I hope to see you or talk to you guys this week. Okay, bye.